Hello, I'm Sam Chapman from the Floow, and I'm here to talk to you about enabling large-scale road assessment programs using mass telematics behavioural data. So first of all, the Floow, just who we are and why I'm here talking to you today. The Floow are a company that supplies services to the insurance industry. We do this the world over. In the UK, we supply Direct Line, Aviva, and a range of other products that are looking at the mobility of vehicles as they move in order to understand their risk. We do this the world over, but within the UK, that gives us billions of miles of data, and over a million kilometres is added every day, even in these decreased travel times of COVID. This gives us a tremendous amount of data from which to understand behaviour. Now, in our core business, we use this to understand the statistical risk of individual drivers. And this uses a range of data capture technology from smartphones, in-car electronics, and box-based devices fitted into vehicles. However, that doesn't necessarily help you understand locations, but behavior does differ by place. These particular orange blobs that are moving across the screen at the moment is raw data, not corrected for location, but raw data. And it can show you that there's a range of different behaviors of vehicles exiting this particular junction onto the same road. So actually, behavior differs quite widely, even in one individual instance, just with a simple pulling out of a single junction into a road with very little contention. So how can we use this data? Well, first of all, we wanted to review what is a road assessment program. From our point of view, a road assessment program is one that is using data from a variety of sources in order to gain a picture of the estimated risk across a large section of the road network, such that it can be used to prioritise where spending could occur in order to mitigate that risk. So road assessment programs typically use censored vehicles that will travel down the road, recording information as they go, because it's important to gather information across all aspects of the road as it travels. They will also use information from either ground-based sensors or infrastructure sensors that are going to inform about the nature of the network at different points. This is then encoded, and the information related to the specific conditions of each individual stretch of road is encoded in such a way that the correlations between these particular aspects can be traced back to incidents that have occurred in the past to provide an estimated level of risk. Here's an example from the West Midlands whereby a large number of roads have been encoded, giving a colour-coded system in this case in terms of their suitability for risk on their roads. The black roads are the worst, red's not so good, green would be good, but there are no green in this particular example. So how can we use telematics data to enhance such programs when road assessment is looking across a very wide range of roads in order to determine where to spend money to prioritise road safety programs? To study this, we've been involved in a research study based in the West Midlands and working with the local authorities there. This was funded by the Department for Transport under a TTRIG research innovation grant, and worked closely with the Road Safety Foundation. This project was evaluated across the entire West Midlands, over every road in that area, using several years of data in order to determine the behaviour that's occurring on those roads, to pick up information that we can use to try and see how to improve road assessment programs. As an example, we're looking at this in different times of day. We're looking at under different conditions to try and determine how those behaviours change and how they influence the risk. This is an example whereby you can see the accident locations occurring in the evening rush hour, so the 4 to 7 peak in this particular part of the world, which is leading to those accidents which you can see plotted across the West Midlands. The road assessment programs themselves that undertake in this area focus primarily upon the gathering of information to indicate what could be fixed about the infrastructure. And obviously there's lots of features that you can then look at in terms of the signage, in terms of the quality of the road, in terms of its visibility around corners and so on. And all of these features are used in terms of road assessment programs with prior correlations to known risk that can give an estimation for the likelihood of accidents. Now these, however, despite the fact with a safe systems approach, where obviously the infrastructure is one aspect, the vehicles and behaviour all come together to create aspects for risk, but focus more on the infrastructure side. However, behaviour is highly important and does vary by location. Within road assessment programs at the moment, however, there is not much in terms of the way that behaviour is actually captured. That information is typically fed in with information such as speed data, mean or 85th percentile, and even in those cases, the quality of that data may not be perfect for the situation and the location. So how can we improve this? We've obviously looked at a range of different capabilities to investigate what data could add value in road assessment programs to understand where there is more risk in the network versus less. So we've looked at this across a range of features from mass driver behaviour to understand typified behaviours and the range of that typified behaviours according to the locations. And this is for every segment of the road across entire large regions. So this builds up information related to time, so the time spent accelerating, decelerating, braking, how much time standing or cruising within a particular environment. Speed related to the aspects of what actually is the level of speed, which obviously has a direct impact of risk, of which we all know. But also the range of that speed. Is it actually very volatile from very low speeds to high speeds, or is there a mixture in between? Acceleration rates in terms of the range of accelerations or the extent of those accelerations. Stops, where traffic is stopping and starting. Obviously, you get a lot of shunts and behaviours around certain areas of the network where a vehicle stops more suddenly. And looking at the degrees of these obviously can help impact and understand risk better. We also looked at the dynamics related to calculating the complete physics of every vehicle passing and calculating that on means and extent in terms of the locations, because obviously the more kinetic energy at a particular point, the more likelihood of the severity of an accident that occurs there. So all of these aspects are being looked at in order to evaluate the types of risk that we find on the network. Here's an example, maximum speed, an easy one to understand. Is looking in particular at Tuesday to Thursday in the morning rush hour. And you can see across the West Midlands the range of speeds that people are driving at. Of course, there are obviously many excesses there in contravention of the road speeds, but it gives you the idea of the extent that drivers will get to. And that can obviously be looked at on a wide basis to determine, is there a differential level of risk on these roads or not? Now, looking across all of those factors, we find that some of them are easy to add into existing models, and some of them are not so easy to add into existing models, despite their capability to give a new insight into risk. Focusing on the long term, there is a range of aspects that do need to be looked at in more detail. However, they're beyond the extent of the study. What we've focused on primarily is those that can actually make an immediate difference and be deployed widely to make an overall impact in road assessment programs to improve their understanding of where risk lies across the entire road network. So to do this, you may notice operating speeds again on this particular image, which is giving us the picture of speeds that are applied in a model before telematics speeds were applied. And you can see here that the colours are very blocky. Long sections of roads in the same sort of colours. And this is not untypical in road assessment programs, but they're taking information from other forms, either the passage of the assessment vehicle or the knowledge of local transport models or actual direct measurement on those roads between known points. However, between those known points, there's no indication or knowledge or data that says how vehicles speed up or slow down. Each of those roads tends to have a fixed speed, which all vehicles are travelling at. Of course, the reality is very different. Vehicles will speed up and slow down on those individual roads. So how different is that, and does it make a difference for understanding of risk? It's actually quite wide. There is quite a wide difference whereby speeds can be observed, but greater or less by at least 30 kilometres just in the small sample region, whereby we can see that there's quite a wide range of behavioural differences in terms of the speeds from that which is encoded into models looking at those estimated risks. Now, this obviously has an impact on the usage of these models because the information you put into them may not be perfect. In fact, if we take this through to a conclusion, we can start to see that there's a strong difference between the levels of estimated risk that the speed differentials then accrue. obviously large portions of that road are actually in the same space. The fatality estimations are not adjusted up or down for either fatal or serious injuries. However, either side of this, there are differences over the entire network where areas of risk are elevated or decreased depending upon the behaviour of vehicles on that particular section of the road network. And this is important to note because we need this best quality information to better understand where we need to apply change to the road network to deliver best savings for road safety. If we look at this across a road in particular, so this is a 4,000 metre long stretch of road, and over this it's broken into various sections, and you'll see each of them has an assessment of risk. And that assessment of risk you can see on the left hand side is a predicted level of a accident occurring on those particular sections of road. So 0.01, that level of risk would indicate that over 100 years of passage of vehicles on that road at its current level of flow, there would be an accident on average. But of course, they're very volatile. These figures, however, do differ quite highly when you just modify single factors of speed. All other parameters and all other observations of the road network remain the same. Speed is quite important, so getting a fine-grained view of speed is very important in getting a correct estimation of where risk lies in the road network. What we can see from this example, at the start of this journey, the telematics speeds indicate a much higher and elevated level of risk than a traditional speed would indicate. Towards the far right of it, towards the end of this course of the journey, the actual telematics speeds are slower. So actually there's a degree of less of risk than it indicates. So when looking at mitigations, actually it's important to have fine-grained understandings of speed to get to a clear picture of what needs changing and where. This analysis has been undertaken in a way looking at road assessment programs and is now being used in wider road assessment programs in the UK so that we can get to a better understanding of where to prioritise spend in the road networks and where risk is lying, such that closer investigations then can be undertaken. What I would like to say in conclusion from this summary of where we find ourselves at the moment is that there is a range of future work that can be done in this area. There is clear value in new data that can add to road assessment. However, despite this, the low-hanging fruit and the thing that should be done now and a core recommendation is such that all programs that exist now should use high-quality speed data. It is vitally important because it does lead to a very strong differential in terms of the outputs of those road assessment programs and where risk is seen by having accurate and quality information put into those systems. This is a key recommendation from this project at this point. However, of course, there is further desire to include further road assessment and characteristics and factors into future models for understanding risk on a wide-scale basis to help prioritise spend. However, now, please include accurate speed data. It is important. Please do this. Thank you very much.